Now we are looking at determining unknown bases. How can you find the value of an unknown base in a number-based system? Just before I solve these examples on the board, let me take a moment to tick the subtopics we have already looked at. So we've looked at addition, subtraction, multiplication, and division. Now we are looking at determining unknown bases. So let us solve this problem together. The most common way to find the value of an unknown base is to expand the number in the power of the base. You expand the number in the powers of the base. That is the most common way to find an unknown base. But there are other methods you can use depending on the context of the question, depending on how the question has been set. There are other methods you can use. For these ones I've written on the board, I am simply going to expand everything in the powers of the base. And if it's already in base 10, then there is no need for me to expand because base 10 is the normal counting system. So basically what I'm trying to do is, if the base is different from base 10, we will try to convert it to base 10. That is by expanding it in the powers of the base. What do I mean by that? Let me show you. So for this one, solution, we have been told to find the value of x if a 305 base x is equal to 152 base 10. So I'm going to write out this. We have 305 base x is equal to 152 base 10. This is already in base 10, so there is no need for me to expand in the powers of the base. But this, we don't know the value of x. I'm going to expand this in the powers of x. So we have 3 times x plus 0 times x plus 5 times x. Give them powers 0, 1, and then 2 is equal to, this is still 152 in base 10. Now 3 times x squared is 3x squared plus 0 times this is still 0 plus 5 times x raised to the power 0. X raised to the power 0 is 1 because anything raised to the power 0 is 1. So 5 times 1 is 5, and that is equal to 152 in base 10. 0 plus 5 is 5. So I have 3x squared plus 5 is equal to 152. I don't need to write base 10. Base 10 is the normal way of counting. Now I will take this plus 5 to the other side. If I take plus 5 to the other side, it will become minus 5. So I have 3x squared is equal to 152 minus 5. And this will give me 3x squared is equal to, what is 152 minus 5? That is 147. So I have 1 is equal to 147. From here, what should I do? I will divide both sides by 3. Divide both sides by 3. 3 cancels 3. And so I have x squared is equal to, what is 147 divided by 3? Let's take it bit by bit. 3 in 14. What is 3 in 14? That is 4, because 3 times 4 is 12. It remains 2. It remains 2. 2 and 7 is 27. 3 in 27. 3 in 27 is 9. Okay, so I have x squared is equal to 49. For me to look for x, I will take the square root of both sides. You take the square root of both sides. Since you need to get the value of x. So this now becomes square root of x squared is equal to square root of 49. But when you are taking the square root of the other side, you introduce plus or minus. Introduce plus or minus because the value of x could be positive or it could be negative. So this square is cancelled by this square root. I have x is equal to square root of 49 is 7. So I have plus or minus 7. So that means that x is either plus 7 or minus 7. But you know that we are dealing with number-based system, and it is not possible for you to have a negative base. No, it is not possible for you to have a negative base. So we are going to take the positive value, and that means that x is equal to 7. So the unknown base we are looking for is base 7. Plus 7 is still the same thing as 7, by the way. Alright, now let's look at the B part of the question. For the B part of the question, we have 101 in base x is equal to 122 in base 4. It is similar to the A part of the question, except that we are converting this to base 10. So we have to expand this in the powers of the base. Expand this to in the powers of the base, we would have 1 times x squared plus 0 times x plus 1 times x. This is raised to power 1, this is raised to power 0. Then expand this as well in the power of the base. So that means we have 1 times 4 raised to power 2 plus 2 times 4 raised to power 1 plus 2 times 4 raised to power 0. Now 1 times x squared is still x squared plus 0 times this is 0 plus 1 times x raised to power 0 is 1. So 1 times 1 is 1 is equal to, then for this we have 1 times 4 squared. 4 squared is 16 and 1 times 16 is 16 plus 2 times 4 raised to power 1. 4 raised to power 1 is still 4. So 2 times 4 is 8 plus 4 raised to power 0 is 1. 2 times 1 is 2. So what do we have left? We have x squared plus 1 is equal to 16 plus 8 is 24, and then 4 plus 2 is 26. So we have 26 here. I will take plus 1 to the other side. By taking plus 1 to the other side, I have x squared equals 26 minus 1. If plus 1 crosses the border, that is the equal to, it becomes negative. So I have x squared is equal to 26 minus 1 is 25. And so taking the square root of both sides, x squared is equal to plus or minus square root of 25. So this cancels this. I have my x is equal to plus or minus 5, meaning that x could be plus 5 or x could be minus 5. But of course, we know that we are working with number-based system and we can't get a negative value in number-based system. So we take the positive value. So that means x is equal to 5. This is the unknown base we are looking for. Okay, let's now go to C. Let us solve the same thing, the same method. We're using the same approach for question C. Let's do that together. Using a similar approach for question C, we have 641 base x plus 156 base x is equal to 807 base x. I'm going to convert each of them to base 10. I'm simply going to expand in the powers of the base. So for this, I have 6 times x raised to power 2 plus 4 times x raised to power 1 plus 1 times x raised to power 0. That's for the first one. Let me put it in the square brackets. Plus, then moving on to the second one, we have 1 times x raised to power 2 plus 5 times x raised to power 1 plus 6 times x raised to power 0. Then is equal to the same thing for this. Let me just do that here. 8 times x raised to power 2 plus 0 times x raised to power 1 plus 7 times x raised to power 0. So this 6 times x squared will give us 6x squared plus 4 times x raised to power 1 is 4x. 1 times x raised to power 0 is 1. 1 times x squared is x squared plus 5 times x raised to power 1 is 5x plus 6 times x raised to power 0 is 6. 6 times x squared is 8x squared plus 0 multiplied by anything is 0 plus 7 times x raised to power 0 is 7. Okay, so let us add like terms together. Let's add like terms. This is 6x squared, this is x squared. What is 6x squared plus x squared? That gives me 7x squared. Then this is 4x, this is 5x. What is plus 4x plus 5x? That is plus 9x. Then plus 1 plus 6, that's plus 7, is equal to the other side. I have 8x squared plus 7. Now I would transfer this 7x squared to the other side. I'm taking, okay, you know what, let me just bring everything. I can do it both ways. The next thing I'm going to do now is to transfer everything I have here to the other side. I'm taking 7x squared plus 9x plus 7. I'm transferring everything to the other side. If I do that, that means I'll have 0 left here. So there will be nothing left. I have just 0. Then transferring that, yeah, I already have 8x squared. So if 7x squared crosses the border and comes here, it becomes minus 7x squared. If plus 9x crosses the border and comes here, it becomes minus 9x. Then you already have plus 7. So if plus 7 goes to the next place, it becomes minus 7. And so 8x squared minus 7x squared, that's 1x squared. But just write x squared. 1 can be invincible. Then minus 9x, then plus 7 minus 7 is 0, and that's still equal to 0 here. Okay, so from here I'm going to factorize out x. If I factorize out x, that is, what is common to x squared and 9x? What is common? What letter is here and what letter is here? X squared means that you have x in two places. So there is x here, there is also x here. So I'm going to bring out just one of the x's. If I bring out an x, I have x into, there are two x's here. If I take away 1, I have 1 left, minus, if I take away x from 9x, so it remains just 9, and that is equal to 0. So you can see this is a quadratic equation. This is how you deal with quadratic equations. Now, from this place, I'm going to equate each of them to 0. So I can say that x is equal to 0, or x minus 9 is equal to 0. This one has gotten to the final stage, but this can still be worked upon. So I can say x is equal to 0 plus 9, and x is equal to 9. Okay, so we have two answers here. We have 0 and then we have 9. Which of these two answers do you think is more appropriate for this kind of question? You know, we can't have base 0. There is no such thing as base 0. So that means that the correct option we are going with, the correct answer is x is equal to 9. So this is the unknown base we are looking for. I hope you understand what I have discussed in this video.